Okay, I hope that you have taken some time to look through this problem. And so now I'm going to go over it and we can see how our answers compare. So it says Bird Baths Unlimited just added a new bird bath to its product line. Find the amount of water it will hold if it were to be filled to the brim, and its inner dimensions were formed by the region bound by x equals -1. So let's start looking at these. So let's find x equals -1 is right here. The x-axis, x equals 3, y equals 6. I'm going to erase this little chunk here. Y equals 2x plus 2, and y equals 2. And it's shown below because that is a pretty complex description of the region being revolved. So we are going to focus on revolving this region about the line x equals 3. So you can see that arrow drawn in there, but just establishing what we're doing. That is very important because that is what's going to make up a lot of things that we put in our integral when we're thinking about the radius and the height. So if we think back, we are going to base our problem off of the shell method because I am going to think about my related rectangles. So if I draw some of those in, if I draw in this rectangle, I see that the height is being controlled by this function right here. If I draw in my related rectangle in this region, I see that my height is being controlled by a different function. And then thirdly, if I draw in my rectangle at this point, then I see once again my height is being controlled by yet a third. Okay, I'm not wanting to use the disk method because I want to keep everything written in terms of x, meaning that it's solved for y. So we are going to use the shell method, and we know that we need to focus on two things. We need to focus on what is or how is the radius defined, and how is the height going to be defined in all three of these sections. All right, so let's focus on the furthest most section. I will do that work maybe in red here. And if we are going to use the shell method, know that we're going to base off of surface area, so 2 pi RH. So we have 2 pi times the integral. Okay, and then let's think about what is our radius. So if I draw in a radius from my line of revolution all the way to my representative rectangle, okay, I know that this radius is over 3 units long because remember our line of revolution is at x equals 3. But back behind the y-axis, we have negative values. So it would be very tempting to say 3 plus x. But look where my representative rectangle is right now. If I said 3 plus x, that would be 3 plus about -0.5. What is 3 plus -0.5? That would be 2.5. And we just said that the radius is going to have to be greater than 3. So in this case, okay, and like I said, every case is a little different. That's why we can't memorize. Our radius is going to be 3 minus x. What's 3 minus -0.5? That is 3.5 because that double negative makes the positive. Okay, and then what is defining the height of our representative rectangle that is parallel to the axis of revolution? Y equals 2. So it's written in terms of x, even though there's no x in it, so we can plop a 2 there and know that we differentiate with respect to the opposite variable than what our axis is representing. And then we think about what region are we zeroing in on. We're zeroing in from -1 to 0. Okay, so that is our first, that is going to find the volume of when we rotate that first region about the line x equals 3. So now we are going to look at this second region here in blue. And if I look at this representative rectangle, okay, and I draw in a radius to that rectangle, I know that it's going to be less than 3. Okay, so 3 is kind of a key number here. So when I look at this integral, I am thinking, well, if it's less than 3, I know that 3 would be to the y-axis, but I need to eliminate this chunk right here, which would be represented by x. So I, in this case, am going to be taking 3 minus x again. Okay, which seems weird, but try it. If we have a representative rectangle at 1, like we do in blue, what's 3 minus 1? 2. And this radius is definitely 2 units long. So it works. Sometimes I have to try it by example. And then what is defining the height of my rectangle? The function that they gave us, which is written in terms of x, we like it, 2x plus 2. Okay, so when we have vertical rectangles with the shell method, we're writing everything in terms of x, which is opposite of the disk method. And then we have dx. And where are we going from? We're going from 0, no gaps are allowed in this solid of revolution, all the way to, do I use the 2 or the 6? Well, we have to use what's on the x-axis, so we're going to 2. All right. And then finally, we need to look at the third region, and I can do the third region in green. So if we look at this representative rectangle, okay, we know we're still using shell, so we have 2 pi times the integral. And if I draw in the radius again, even though it's small, we're still basing it off of 3. Okay, that number of the axis of revolution is going to show up. So I want to take away where we're at. So if we're at 2.5, okay, 3 minus 2.5 is 0.5, which that is looking like it matches what we see. And then what is the function or the third function that controls the height of this third rectangle? It's the line y equals 6. It's constant. Every rectangle in this third region is going to have a height of 6. That's what happens with horizontal and vertical functions. Okay, and where are we going? We're going from 2 all the way to our axis of revolution, which is 3. Okay, and so with these, what am I going to do? I am going to add them up to get the total volume of what the bird bath can hold. Okay, so now it's just a matter of correctly plugging these into the calculator or correctly working them by hand. Okay, so what I'm going to do is we're going to simplify a little bit. So we have, I'm going to rewrite each integral actually. So I have 2 pi, whoops, sorry. Okay, so we have 2 pi times the integral from -1 to 0, and we have 6 minus 2x dx. And then in blue we have 2 pi times the integral. Okay, we're going to FOIL and we will get -2x squared plus 4x plus 6. I'm not showing the steps of doing that, double distributing. Okay, and then finally we have 2 pi times the integral from 2 to 3 of 18 minus 6x dx. Okay, so when you go ahead and evaluate each of these integrals, which you could definitely do these by hand, all of these activities are made so that you can do them without the aid of an integrating device, but that's okay if you did so. Okay, so if we look, this integral in red is going to give us 2 pi times 7 if you evaluate it from -1 to 0. The middle integral is going to give us 2 pi times 44 over 3. Now obviously I worked this problem beforehand. I'm not doing all of this super quickly in my head. Okay, and then the third integral, we have 2 pi times 3. And we said we need to add these three quantities up. And when you add them up, you get a total volume of 148 pi over 3, which is approximately 1.54 or 154.98. Am I going to make it? I knew I wasn't going to have room there. I'll write it on the top here. 154.98, and we were measuring in, it looks like inches, so we're going to properly put inches cubed. So that is the volume, the amount of water that this bird bath would hold. Okay, so the moral of this problem is sometimes with the shell method, you certainly still have to break it up into multiple integrals. Okay, and you have to be very, very careful when you are determining that radius for the problem. Okay, now on the second spring is sprung of the day, which you are going to do on your own. Okay, I am asking that you use shell method, so what you have to do is be very careful when you determine the height of your representative rectangle. Okay, you have two functions defining the height, so this is similar to when we use the washer method, but you need to make sure to establish, okay, what is that radius? And the height is going to utilize both functions. That's my big hint there. Okay, so make sure to take your time, double check your work. You have the opportunity to get extra credit on this second problem. Keep working hard, keep trying to master the shell method and master allowing the disc and shell method to come up in different problems depending on which one works better. Good work and good job this week.